Newton's law of cooling. Newton's law of cooling states that the temperature of an object T is a function of time T. Uppercase T is the temperature, lowercase t is time. Changes at a rate means derivative, proportional to the difference between the temperature of the object, which is T, uppercase T, and the temperature of its surroundings, Tm. That's the temperature of surrounding or ambient temperature, and we assume that Tm be constant. That is, the rate of change of temperature, dT over dt, so rate of temperature is the difference between the temperature T and some medium surrounding T minus Tm, and proportional means that equals negative K. Negative in the sense the temperature is decreasing. The rate of temperature is negative because the temperature is decreasing. And this is a separable ODE. We have two variables, uppercase T and lowercase t. Tm is constant, K is also constant. Now we can rearrange the terms, just basically bring T minus Tm to the left. So 1 over T minus Tm dt and move dt over, so negative K dt. Now we can integrate both sides. Then natural log of, we are saying T is bigger than this surroundings. Decreasing means this is always already positive, so I'm not writing absolute value. Natural log equals negative Kt plus C1. Exponentiate both sides. If we exponentiate, we get T minus Tm. Now I'm just saying T is a function of T. That was written just T there, but in fact T is a function of T, equals e raised to negative Kt times e raised to C1, and e raised to C1 just be C. And now let's say the initial temperature is just T sub 0. Okay, temperature at time 0 is T sub 0. It's still unknown in this case, but this will be given in the question. Using this initial temperature, we determine the value of constant C. Okay, just plug in here, T naught minus Tm equals e raised to 0 is 1, so C, that's the constant. Plug back here, so Tt minus Tm is C is now T naught minus Tm. E raised to negative Kt, we just move Tm to the other side. So the temperature of that object at any time T is given by temperature of medium Tm plus T naught, that's the initial temperature, minus Tm, that is in fact the temperature of medium times e raised to negative Kt, where K is the rate of decrease, and it will be positive. This negative K will be negative, K itself will be positive. Okay, final.